Good afternoon. Engineer Suraj Singh speaking from Bharat, India regarding formula generations, formula demonstration on worksheet. This is November 17th, 2020. This is in continuation. This file I started on November 15th. In continuation of that, last time we discussed ax square plus bx plus c. Also we discussed ax cube plus bx square plus c equal to 0, equation 3 with it as we say. Welcome Mr. Vijay. Equation 3, then ax cube plus bx square plus cx plus d, and also equation 4, wl square over 8. And also, as we discussed last time, wl square over 8, which is the engineering formula of bending moment. Also we discussed wl square over 24, as bending moment fixed simply supported, fixed minus simply supported, and also we discussed complex 5 brackets formula, and we discussed complex formula with 5 brackets again, and trigonometrical functions. And also now later on we discuss a plus b into a minus b equal to a square minus b square, how to validate that. A plus b plus c whole square, a square plus b square plus c square plus 2 into ab plus bc plus c, how to validate that. And then a plus minus b whole square, a square plus b square plus minus 2ab. And also for a plus b plus c plus d square, so a square plus b square plus c square plus d square plus 2 into ab plus ac plus ad plus bc plus bd plus cd, bracket close. And now I'm going to start certain geometrical formulas. Let me write title here. Geometrical formulas just for change. Let me see geometrical formulas. Geometrical. You can say geometrical formulas. I can say here formulas. These simple formulas means you can say mensuration like based on geometry. So I can just say that one. Geometrical formulas in this. There's a few formulas only, means not many. It's, for example, square, it's rectangle, and it's triangle, and it's equilateral triangle, it's isosceles triangle, it's right angle triangle, it's circle, it's sphere, cylinder, cone. These are very, very basic formulas. Everybody needs somewhere in career or in education, even school kids need these formulas. So if you know them very well, that will be helpful to guys who are studying them. Means that will be good enough if you have that basic knowledge, because somewhere you need these formulas from whatever aspect. It's only you need square meter, you need perimeter, you need diagonal. Like that, we need somewhere in our life something. This is even, but sometimes we have to calculate. So, what actually we want to do is just to help, means to broaden your mind after these few geometrical formulas. You will see to continue these or to add something more. I've already prepared certain graphics, certain cellular information for these formulas, and I think I didn't like to take your time more than required, so I prepared some already homework. A format has been, you can say layout has been laid, so it will now be changed depending on requirement. I'm just doing this for sake of easy going calculations. Now let us say square. After all, what's square? You all know square is a figure, 4 sides are of same dimension, 4 sides are of same length or same, what do you call it, same dimension. That's the important point, square. So I say side is A, I can say this side is A, and this is, I can say A, we will say A, and this is, you can say, let us say 5 meters, it is 5 meters. So we can say here it's 5 meters. It's 5 meters here. We write here 5 meters because unit is 5 meter. Now area we have to find out. How to find out area? We know very well the square is length into breadth, and length and breadth are same. So area should be 5 square, 5 into 5. So we can say plus same dimension divide power 5 power 2. This is area. So it's area, and we can write here a square. A square. Square. That's it. This is area. This is one answer. Now it's very easy, means there's nothing as such I should tell you, but just because we are doing something for purpose of understanding by everyone. Now perimeter is, means in case of square, perimeter is, say A is 5 here. So because there are 4 sides at 90 degree or right angle in a square, so it should be, let us say, we say plus 5 here, plus this one, C5, this is dimension, and this is 4. 4 you can write here, or you can write this end, doesn't matter, let's say, I write here 4 into this. So this is 20 here, because it's 5. So this is perimeter. पानी गिर रहा है? यार hold on please. पानी गिर रहा है क्या? अच्छा अच्छा. So it's 20. Perimeter is 20, and this is, we can say, 4 multiplied by A. Multiplied by A. This is formula, and this is its answer. Also, diagonal is very important, means how to find diagonal. Sometimes you need diagonal of that. Yes, you can find out by calculations, and formula is 2 into A is dimension, this A, we say height square into this, so here both are same. So A square plus A square, that is 2A square, and that's under root. So what we say, this formula is here. So we can bring down this formula into this one, and put here, so that it's clear and symmetry. So let's say what we say, plus bracket, it's 2 into A square. Let's say 2 into A is 5 square, 5 square, bracket close, because this formula is done. And then it's under root, and when say under root, we have to power it by 1 over 2 or 0.5, right? Either took under root there, so we do 0.5, you can say, whole power. Here it was A square, 2 into A square, because this square plus this square is 2A square. A square plus A square is 2A square. And under root of that, so we can say 0.5. So this is 7.07 for 5. So again we see 2 AC 65, 2 into A square over 0.5 over this power sign 0.5. So this is, because it is a root, 7.7 square meter is meter, diagonal is in meters, so this is meter. So we found that. Okay, so now what to do? We got diagonal here, and this is value. So we got 3 parameters of square. We have area, we have side, we have area, we have perimeter, and we have this. Now in this case, what I said important is A5 is variable. It can change. 5 can be changed here very easily. And how to do this? Let us say it is 3. You see, all values change immediately. Let us say it is 2. These values change. Let us say it's 25. These values change. Let us say 15.25. Values change. Let us say 20. Let's say it is, you cannot say minus in this because this is figure. Let's say 125 is changed. So you are getting everything changed. So let us keep 5 again. So this is our open cell. This cell is open cell, you can say. Well, again I say open cell or editable cell. This is open cell. So this is connected to this one. or I can direct some, leave that. No, now, come on. If he has a remark column, you want to write some remark, you can write in that or you can remove that, no problem. If you have some remark. Now, let's say go to rectangle. Rectangle. Again, A is 1. I'll say, let's say length equal to A is better. Length equal to A. Oh, sorry, A meters and width equal to B meters. So we can take down directly like that. Okay. So it's that. So, okay. And then we can say area as it is, L into W, square meter. Perimeter also, you know, when we say perimeter here is A plus B and twice of that. And diagonal is this. That's again, we have A square is one side and B is other side. So A square plus B square. Sum of these under 1 of 2 or 0.5, you'll get diagonal. So let's try this as well. Let's say this is A, this is B. So we have only two variables here. Let's say now one variable is say 5 and other variable is, let us say, 4. We have two variables, length and breadth. So this is that variable. Let's put them also yellow and hash it. And you know, we can say, so these are variables. Now we want area. This into this we want plus this into this. So simple it is. So this is answer of area. We got area here. So we got area here. So simple. We are just simple, but it will be complicated later. No worry. This is answer here. This is not changeable. Just like area is not changeable here. This is change. Only 2 you can add it. And these are open cells. So you can say open cells here. These are. Now perimeter A plus B, and that is into 2. So we have direct formula. That is 2 into A plus B. We have A plus we have B. Which is that one. So this is this formula. We got 18 here. In this case, this is 2 into C plus D, 70. This is 70 plus 70. By chance, if I cut this whole and put here, everything will change. You know that? You got my point. This table is just, I'll show you something. As usual, you know, if I cut and paste somewhere else, all linked cells will move like that automatically. You need not worry about that. For example, I'll show you how it works. Just in beginning so that you can have clear concept about this. Clear concept is that suppose for example I took this here. I put this completely cut here and put here, you know. Say, you see, nothing has gone, everything is here. But all this changed, all changed, okay? All this changed. Cells location have changed, cells address have changed. I bring it back there, okay? Just for your, so what I say here is gone. Yeah, square. So this is that. So I say in rectangle is there. Diagonal is already there. I put diagonal here. It can be reduced in its decimal places. So we can bring it to say 2 decimals. Okay. And now perimeter we got it. See, now diagonal of rectangle, because there are 2 dimensions, A and B. So you say A square plus B square, sum of that, and under root. So its formula written already there. What we do same. We say square. A square. A is that, we'll put A square plus B square. We say B square, bracket close. And then it is under root means we have to do further, we have to take it power. So we'll put another bracket here. Let's say we put another bracket here, so that it's done double bracket in this case, and we say power 0.5, and that's answer. So we take it to decimals places 2, and we say okay, it's fine. So that's answer of diagonal. So perimeter, this and diagonal we got. So what else you need in this? Nothing, because area you have and perimeter you have and diagonal you have. So if you want to measure diagonal, you can do this way as in square as well as rectangle. So there's no problem at all, you know. Now what I did actually, I formatted this portion so that size of this font is equal to this. And if I say no, this should be centered one. So this can be centered by using controls, and we get this. Both central one. I mean to say this is central one. This is okay, we have done this, and this is central one. And this is format painter. Okay, now let's move further. This is for rectangle. Now we are going to triangle. Triangle, very normal triangle where base is given. This base is given. That is B. Height is given. That is HM. Let this is down. So height is given HM. Area is half of base into height. And apex I mean to say top corner of triangle, I'm calling the apex. That is that is a distance C meter from left, and there's another other one that's at from right hand, that's distance, you may say apex at C meters from left, so apex at C meters from right, so it can't be same, so let us say D here, you may say D here, so D meters from right, from base and left hypotenuse and right hypotenuse, because there can be different apex is not necessary in center of base, it can be either this way or that way, and then we have to see perimeter. So let's say what we have to do. Actually, let us say this is B here, base. This is, this is H is height. So we keep this same. These are main points here. Let us say 10 is B, 5 is 5 is 5 is base height. Sorry. So it looks very simple in this case till now. So this is open cell. We can see cell is open. I can say if not coming itself, so we'll write from here. It's not coming here, no. So I thought it should be here. So it's a open cells, and these are variables because we have to change them once again and again. So the basic change. Now height, now half into base into height is formula. Half is base into height. So what is half? Half is normal. That is 1/2 into base into height, because there is no sum here, no bracket here. Base into height. We can get this area. Area of this triangle. This is now not variable. This is uneditable cell of this. So we say even if you take 10, 50, 25. Now we want to see apex at C meter from. Let us C is from C from, I mean to say, let us few meters. I do not keep it in center basis by, let's say, on one end it is 3 meters. So from that it is 3 meters. You got my point. This is a variable here. I'll take this variable, and it is 3 meters, and apex at D. D is how much? The question is there. C is how much, and D is how much? That's point here. So we take this C and D because C is 3. So what is D? This minus this. D is equal to B minus how much? B minus A. B minus how much? We have to see A, C, D we can find is B is here 10 minus C. So let us say how much is B? D is equal to B is how much? B is this minus C is this. So we got 7. It's so simple. This is not variable. Don't worry, this is variable. Either this is variable or this is variable. One of them is variable. Both can be. Now we got what? Area we got. Now area we got. What's important is area we got. Now we have to find for its perimeter. We should have all three sides of triangle. So we have got 2 sides here. One is base, one is this. But this height is there. Height is not side. Height is just an indicator. So we will suppose this is a triangle here. This is a triangle. So this hypotenuse and this hypotenuse we must know, because this is not symmetrical triangle. In this case, what we do, left hypotenuse and right hypotenuse we have to work out. So what is left hypotenuse in this case? because C is 3, from left it is 3, we have 3, and height we have 5, so 3 and 5 we have to find hypotenuse based on this meters, based on, you can say, based on 3, based on the what, based on C and B minus and D, based on C and H, C and H. This is what we have to find, Based on C, here C we have distance from left, that is 3 meters C, and H is height, H is this. So we can say C square here, we can say C square plus H square. So let us say equal to, you can say C square plus H square, this formula, and this formula is here, and we will say bracket, put a bracket in, and further power 0.5. So this is formula, left hypotenuse based on C equal to H is equal to height is equal to C square plus C is this one, left is C, H is plus H square this, and similarly here will be D square. So we can say right hypotenuse will be, that is D is equal to B minus C. So in place of C there will be D, that's all. So we can take it, we can say from here we can copy it, let us say here, and we'll change there in this, we'll do here like this. So we can say, so here in place of C we would say D is H is equal to D square plus H square. So we say D square, and that's all. That's what we need. Then perimeter we can find, perimeter is equal to, perimeter is base plus both hypotenuse, that's perimeter M, and that means equal to base, that is B plus C, not C, B plus, we can say, we got hypotenuse, we can say hypotenuse H1 or H2, you may say, you can say this is H1, let us say this is H1, and this is H2, so that we can just, for nomination purpose, we can say H1 and H2, so H1 plus H2. This is our formula that we can use in this forever. So we got X apexes. Now what to do then? Because we have area, we have here all this, so we have to find now what is H1 is equal to C square, let's say bracket, C square, C is what? C is this is square, plus H square, H is how much? 5 square, and this is closed, and further 0.5, we got this. So this is 5.8305, so we'll bring it to decimals, so that's okay. So it's here. Similarly, you got my point? Or no? So we got here hypotenuse H1 on left side, that is C square. C is left to that perpendicular high, and this location of apex. C square plus H square, H is common in both cases, under root 10. So this is 5.8, and if you take this H1, so we can say H1 this is, and H2 is this one. H2 is here and H2 is there. So we can say now we have to find H2. So what we do same thing. We'll take bracket, and then we'll say D, I think D square, D square, it should be, I missed a square here, I think. C square, so here also I missed something, so let me finish correct that one. By mistake 2 is left, and also here by mistake 2 is left here, because this is square. So this is corrected now, okay. So now we say H2 is equal to D square plus D square. D is, where is D? What was D? We have to find D, right? We found somewhere. Yes, this is D here, B minus C. So this is D square This is d square. Wait a minute. Something wrong somewhere. Yes. C is 75. This is d square plus h square, and h we know h is same, h square, and this bracket close, bracket 0.5, let's say. So we got second one, so we'll take this in middle. So we got h2. Now what we need, we have base, we have this left hypotenuse, we have right hypotenuse, so we can sum up all these three and we get answer of perimeter. This is same as written here, same is coming here, so you can see this is application formula here. So let's say b is this plus h1 is this plus h2 is this, so we got this formula. This is our I'm to say sorry here, yes, and what you can say, we got perimeter. If there's any remark, you can write that remark, not necessary. It's up to requirement, means it's up to requirement. If you wish, you can write. Not necessary, just for purpose of this, we are given this. Okay. Now, I think we got it. Triangle is done here. You know, it looks very simple. So calculation is simple if you do every time. But I don't have every time I want to do, okay, I want to just formalize it forever. I don't do it again. It's a kind of automatism. If you want to do it, you can do it. If you don't, let us say, I make it 50 and make it 20. This I make it instead of 5, make it basis 5 and 15. You see, everything has come again without any effort. If I make it 1000, for example, 1000, I make it 350 height, and I make, because 1000 big one, so I say 250. We're going to get an answer, you know. That's beauty of this formalization, and you need not do it again. If there's an error, you can check that, but it's done in this case. So we can say we'll keep as it is, as before and as usual. So this is what is beauty of formula. And now we will move to next one, and that is equilateral triangle. You know what is equilateral triangle, whose three sides are equal. There is no ABC, base equal to left hypotenuse as well as right hypotenuse. That's called equilateral triangle. Each angle of three angles are 60 degrees each in this equilateral triangle. You know it very well. For example, I should say three angles. We say three angles equal 60 degrees each. Equal 60 degrees. You can say each. We will say that 360 degrees each. Okay, this is just for information. Now, what actually we have to do? Equilateral triangle formula, if area is under root 3/4 into a square, and perimeter is equal to 3 into a. So simple it is, you know. So under root 3/4 a square, and what is a? A is here, side A, side, this is side A, let us say side or something, you know. Side A is A here, it's A, and let us say it is for 5. Let us say it is 5. For understanding it's 5, we can just bring its sign to here, it's 5. So under root 3/4 a square is direct application of formula. So we can say under root into 3/4. So under root into 3/4 a square. Yes, you can just put it here. If you can bring it here. So now what to do? And perimeter is there. So what to do? It's very simple actually. Area we can say here is, this is, you can say area what is the area of this? Area means meter square or square meter, you may say, same thing, just for addition. What I do now, it says first of all 3 under root, then forget under root, let's say 3 or 4th, let us say plus 3 or 4th, 3 or 4 into a square. A is how much? 5. So let us say square. First of all, let us say this is done. It's not answer completely, let us say it is done. 3 or 4 under root we have to take, right? 3 over 4 a square under root, that is equilateral triangle. Here 3 or 4, now under root we have to take this and then power 0.5. I'm sure this is that formula, 3 or 4 a square. A square means it's a square, means a square, but this is 1/3 of that. So it is 3/4. Let me see file. What I need is area equilateral triangle. There's a file of formula. Sometime we have to refer to that file as well, but it's not, I don't see. Anyway, we'll see now parameter. First of all, let's say parameter. Now this is open cell, so we keep this open cell. This is open cell here. We can say open cell here. Parameter is 3 times a. It's very clear because the 3 sides are equal, so we can say parameter here. Parameter, that is 3 into a. Okay, parameter is equal to this much, so 3a. Because it's already written here, so I will not write this. No need of writing this. Only say meter. That's it. So it's so simple. Means either you say plus 3 into 5. So we got this. So this is very simple. In this case, there's no need of diagonal or something. So if you want 25, it is now. So you can say it is this one. Formula is a 3 or 4 into a and 3/4. I think 3/4 is separate than a square. This is a matter, I think. 3/4 is now. This is actually. It's okay. It's 3/4 into a square. 3/4 under root into under root 3/4 into a square. Yes. Just a minute. There's some I think some confusion here. Let us be clear about that. E is there. Let me open this file just for more, please. Mathematical. I'll take a formula. What was that file? Formula. Geometrical formula. Formula demonstration. That's file. Where is this? Yes, I got this. Okay. This manipulation reduction types are the properties and solve examples. So maybe I'm not sure for the revision that will drive that actually. So let us see what it says. Association store. Okay, now hold on please just a minute. This file is opening. This file is opening. Just a minute, please hold on. I'm just looking after that file. Some problem in computer. No problem. Let it open. We'll move further by that time. I'm back here. Let the file move. No problem here. You can move this file. 35 minutes over, so no problem. Let's say. If that file opens, it's fine. My computer is failing here, I don't know why. Yeah, it's opening. So yes, it's open now. You can't see this file because this is different format. I'm just searching for what formula was there. This is for equivalent area 3 over 4. Area is 3 over 4 into side square. That's equilateral triangle area. I think under root is an error there. So it is 3 over 4 into 3 under root 3 over 4 under root 3 over 4 into side square units, and parameter is 3 into side. So under root 3 over 4, it is under root 3 over 4 into side square. So let us be clear about this. It's different one. Under root 3 over 4, under root 3, this means 3 to power 0.5 divided by 4 into, you can say, into c square, a square. This is a square, and this was an error, so I remove this. So this is that actually. There's some error in understanding. So this is under root 3 over 4. 3 over under root 3 to power 0.5 over 4 into CAT, and CAT is this, that is dimension C, and that is square. So this is that one, and parameter is clear, so it is 10.82 in case of 5. So let us say 5 to 10 or 5 to 15. You will get answers here all same. You can, so in equilateral triangle you got parameter and you got area. So all these are just without anything. We'll see later on what to do with these. And now we go further to isosceles triangle, which is where two sides are equal, base is not equal to sides. You know that both angles, both sides to base angle are equal, and third angle is 180 minus sum of these equal angles. That is called isosceles triangles. So in this case, you can say both sides equal, both sides equal, and base not equal, base different. Okay, so we take like this, just for your information, for general people. Now what we do, now area equal to half into base into height. So we should know base, so we can say base is here, base is m in meters, and that is, let us say, b. Okay, we say b. So b is base here, right? This is base. You can say b is base. Height we need, because area is equal to half into base into height. So we have to take height also in this case. So we cut it and paste it here. And so we can say we have place for height. So we have place for height, and height is this, H-E-I-G-H-T. Height is in meters, and that is H. So we can say here is meters, and that also we say here that is meters, and that is B. So we have H here, so we can say H here. We will say simply, now formula is half into base into height, that is area. So area, of course, it shall be square meter. There is nothing, no meaning right. Even if right, that's fine. Means it doesn't matter. Area is square meter only. So just like here and there, we can write here as well. Meter square. So that's here. Now let's say, simple means we have half into base into height. Half plus 1 over 2 into B into H. This is our formula of area. I think something equal is wrong here. Half into base into height, so that's fine. Now B is how much he can take open cell, we can say here. Let's say open cell here because this is open cell. We let's say 10. Height we can say 15. So we have two dimensions. These are open here and these are open in a sense that these are open. Now half into base into height is how much? Let's say half 1/2 into base into height. So this is 75 in this case. So and then hypotenuse equal sides, actually what we call them. It's difficult to find, but it's easy. We consider this hypotenuse because both are at equal angle. We just from apex, from third point to top. We call it apex to down to base. So imagine there is perpendicular. So base of that perpendicular is half of base. So half of base square plus height square, and sum of that and under root would give you hypotenuse. The formula is written here very clearly. This is, you can say here, we can say base, we can say half of base square, because it's 0.5 into base B square plus height square, this is h square, and sum of them is here, sum of them to power 2 to power under root to 0.5, that's under root. So we can say here that we can do this. So this is the formula. Base half, so remember base is half, that's base and height. So hypotenuse 1 will be 0.5 b square, half of base square. Half of base square. It's not base square, half of base square. So let us say base first, then half. So we can say here this half of base square plus h square. We can say this way. And under root of total under root half. Here is 1, then we can say also, you can say here, let us do it, half of base square, and you can say sum of h square, sum of this whole 1 2, so we can give here sum of this whole, and then all value here, this is square of this and this whole 5. That's what is still got my point. Let's say half base. If I keep half base here, nothing wrong, I think. Let's say half base here plus 1/2. Let us say half base here. 0.5 into base. Base, I can say square of this. For my easy working, I can say square of this. We can say like this. We keep here just for our purpose, and we say half of base this plus 1/2 into base is this, and this is equal to this. So let's say 5. Half of base is 5. No, no, I can say square of this. So this is square of this 25. Now half of this is over. What I say, h square will add to this in itself. So we can say here plus half of base square plus h square, this is h, and we can say h square, this is some value, right? H square is some value here. Let us keep value as it is, and this value is under root required now. For this value here is already square, this is square, and we can take, I think maybe you confuse this way. Let us say this way. I put one column, one small space here, and add something here so that confusion is gone. So here I can say I'll take h square. Let us take h square for easy working. so that confusion goes away. So I take h square here plus h to power 2 square here. So clear point is there. We can easily, now we have sum of these two here, so we can say this plus this is here, this plus this under root. So this is now, rather than that, this is this plus, let us say sum of these two, actually this is, and then under root at the rate of sum. I'm using some formula here just for ease. F 85 G85, F 85 and G85, G85, I think I'm right. So this is 330. Sum of this 330 or 2, something wrong, I believe. Sum F65 G85, F60, 85 it is, sorry, not 65, 85 G85. So this is 250. So we got this formula. 250 plus 250 means this is these both are part of this, you can say. These both are part of this. 5 v square is here, h square is sum of this, and half of this is here. Hold on, this is sum, half of this, sum of this, and sum of this and under root. We just got sum of this, we have to take under root also. So we can say this power 0.5, right? Call it this square value plus this square under root. So this square is here, under root is still 0.5. So we got this value here. So we got hypotenuse, yeah. So what is perimeter then? That is 2 into hypotenuse, 2 into plus base. So this is base is B plus 2 into H. That is hypotenuse. Again, I think this sign will not work here. This is formula sign, so I made a mistake, so it is here now. Now simply perimeter can be found with plus base into plus base plus 2 into H, 2 into H. So we got perimeter here. So you can say 10 plus 30 is already perimeter there. We just see that one. But because its formula is now, if you want to take 200, for example, you take this one, and you can say 75 this one, you will get answer. So simple. So we'll keep it as it is. 10, 15 or 10, 5, whatever you can say. And sorry, it was gone. So it's what it is. So this is formalization of isosceles triangle, though it looked very easy. But you see, it's a longer calculation. It's a longer calculation, not so easy. But we wanted to make it easy, but it is longer than that. So you got my point, I think. You're getting with me. If you're not getting with me, you can ask again. I'll explain again, because without explanation, it's not possible to understand. Okay, though it's very simple formula, in calculation it's very simple. Indeed, it is simple, but it's formalizing, it's computerization. It's not that simple as we think. We have to think a lot in that. All right, now we go to next one. I think it's better to get this simple formula into computerization so that we can understand very well. Now, these are simple formulas, but then I would like to say I convert this square to cube out of 3-dimensional values just in there, and then rectangle also, triangle. I'll see this later on. Now we have 3 or 4 more, I think 1, 2, 3, 4, 5, so we can say for today. We have enough material here. Now right angle triangle. Right angle triangle, you know it very well. Right angle triangle means one angle is 90 degree. When one angle is 90 degree, then sum of other angles means 90 degree, because triangle means 180 degrees. So one angle is 90 degree and sum of other two angles is 90 degree. It can be 45, 45, it can be 30, 50, it can be whatever. It depends upon height, perpendicular, and base is and height is there. We can say right angle triangle means we have base and we have height and right angle. This is requirement. So you can say area is half into base into perpendicular rather than saying height. So my formula is there that half into base into perpendicular. So we can say this way rather than this. Let's say one is base and one is perpendicular. Two items are there. Let's say base. Let's say base B. Base B I write so that it is easy for calculation purpose. We say base and we say P, and we'll explain means what's base and P. So it's here base and P. I write here base equal to base is B, base is equal to B just for reference, and P equal to perpendicular to B, perpendicular equal to P just for our reference. Sorry, it's P just for our reference, it is not for someone else. So base is B and perpendicular is P. So area, I should say area half into base into perpendicular. So I think I should take this here so that it's clear here. So I move this here. This is perpendicular. This is base B and this is perpendicular. Leave it here. Put it here perpendicular. Perpendicular. This is base in perpendicular equal to P. I write just for P. So meters. It is of course we will take in meters. So we will take in meters and we will take it as also meters. Meters. So this is this one. Now, what is area? I'll take now here B, let us say 10, and P I take let us say 20. That is 20, 10 and 20 meters. So I centralize them. I call them open cells here. Open cells. Now we have to find area half base into height, or you can say half base into perpendicular. So area is very simple in this case. We can say here area let us say here area equal to half into base into perpendicular. This means I can say if I write equal, there's a problem there. No problem. Let's say 1 over 2 into base into perpendicular B into P. Let's say that's area. So I can say here alt into enter. So this is half into base into P. Let's find out how much. Let's say these are our cells, which are in this case, and this is a, so right angle triangle we are talking, plus area is half into base, plus half into base into perpendicular. You got this answer. This is half into base into perpendicular. So you got area. We use 2 into 10, 200 or 2. This is now hypotenuse is base square plus perpendicular square under root sum of this. So we can directly take here hypotenuse. You can say hypotenuse h. Let us say h is hypotenuse. That is equal to, formula is there already. So we can say hypotenuse. I don't know. Should represent. Let's say h. We say h here. Hypotenuse will put h. Khalas, no problem. So hypotenuse here h, and formula is there. So we can say plus base square plus perpendicular square plus perpendicular square, and we close this and under root this. So further 0.55. This is that, got it once again. Let's say C90, as I said, C90 is base, so base square plus D90 here is perpendicular, so D90 square, and both we close, and then under root, or you can say square 1 more 12.5. So you get this hypotenuse value here, and this means we can say up to 2 places of decimal, and this is 22.36 in this case. So what is perimeter? We can say perimeter is base plus perpendicular plus hypotenuse. So you can say this is base plus perpendicular plus hypotenuse. So let us say base is how much? 10 plus perpendicular is 20 plus hypotenuse is this. So we got this. You got my point. So we got all three results from this. That's right triangle, base is B, perpendicular is P, and H is hypotenuse. Sum of three, we derived value of hypotenuse, and we use this for finding parameter, and that is what answer is. So if I say in place of 10 I say 25 is there, and perpendicular is 50, let us say, you will see this answer has changed. We got complete answer here. This is what his formula derivation means. So we will go further now. We'll go further on this. So already no problem, we have time. Let's say, because this is mathematics and it's time consuming of course, but once you do it solely on worksheet, you can copy it wherever you want to copy, no problem, you can use it. Now we go to circle, which is very common, and it's common. Its formula is also very simple. Area, we consider R as radius meters. We can consider R in meters, area in meter square or square meter. And we say R here, we have to give R and pi R square. And then circumference, very easy. So how to do? Let us say this is open cell we keep here. It's only open cell here. Let's say here, better. Only open cell here, radius R. We may say radius. You can also say dia out2 is also radius. So we can say d out. Leave it now, radius. And this is R here. Oh no, it should be R actually in this form. And this is form so that we use it in formula. And pi is already there, how it is, and this is pi. If you take here at pi and you keep bracket there, you'll get answer of pi. This is pi, is you can get through computer. So 2 pi r is circumference. So let us say r is 25. Just keep any value. I keep 25 meters. Pi is already there, so we can say it's pi and 2 pi r. This value of pi. Area is not area is pi r square. So I think we just better take some more cut here, because it should be very, very clear here. Let's do it here. Area, we have to shift area here actually. We put area here, and this value of pi. This is pi, so we should not get confusion. So area is here, pi is there, and area is pi r square, and this is pi r square. I think it should be here. Okay, no problem. We'll make it 2, and we'll make it pi only. This is pi. So pi r square, we got value of pi here. So what is pi r square? Now we have to see. We have pi and we have r. It's very easy. You can say pi here. This is pi into r here and r square. So this is a square. We got this, so simple. So we got area here. Let's say here, and now we get just close up here. So we got area. So this is here editable. I mean, variable here. So we got pi r square. We have to find circumference in meters, and that's 2 pi r, pi d or 2 pi r we can say. So let us again say pi is there and r is there and 2 pi r. You simply apply this. So we have all this here. 2, where is it? 2 we have to write directly here. This is not separated. You can write separately. Here we can say, if you want to, its coefficient means you can't change it. So if you write directly here, you can write directly here, and if you don't write directly, it's up to you. If you say 2 pi r, you want to write directly, you can say, then I will say 2 coefficient, I will say coefficient here. This is 2 coefficient. Not necessarily, but if you can say coefficient, you can say this coefficient. So 2 we have the coefficient here and 2 pi r. So it's easy now. Let's say 2 you have plus, don't, now you have to do this 2 into pi, this is pi, into r, this is r. You got this answer, and you can close up to 2 places of decimals. It's up to you. Or you want to keep as it is, keep as it doesn't matter. This is what is this is circle, So you got, if you say 25, we consider this as 15, let us say, it would change. If you say 5, it will change. Or if you say it's 2, whatever, you can say 10, 15, let's say 15. So, sorry, it's gone somewhere else. 15 is same, so 15. So this is what is circle all about. So it's very simple. But only you have to try once, you have to formalize once, and then you use wherever you want to use. No problem for that. Pi d. Now sphere. I think we'll better if we complete these 3-4 formulas. Already 1 hour is over. No problem. No problem. And I think we should do it comfortably. Sphere. Sphere is a ball, is a sphere. Earth is a sphere. You know what is a sphere? Means where diameter is same. And center is the center of sphere. It can be solid. It may be ball, or it may be earth, lithosphere, or wherever it's called sphere. Its volume and surface area we need. Volume is 4/3 pi r cube. That's formula, pi r cube. Let me see correctly. Pi r cube and pi r square. Pi r square. This is formula for this. So again we have to shut it like that. We have to find, say, this is means we have to give space for radius and pi as we did in the above case. So what we do, we now shift it little from here and keep here just for time action, and we put values here in our own way. So we can say r is here, we can say r is here, right? S is there, r is here, so we copied it from there. R is a must, and pi also we take from here. We can say formula is pi, it is, we can say pi, so this formula is pi, it's okay. Then we have to say pi formula is 4/3. We can say 4/3 also. Coefficient, I can say coefficient here. I can say this is coefficient here, right? So this is coefficient here. We can say coefficient here. So this is 4/3 rather than 2. So this is plus 4/3. This is our coefficient. Then we have to see pi is there, r is there. Then we have only this. Means we copy plus here and do it here and delete this from here. So we have now our formula cell here. We have to dip here and find out what is that. We say 4/3, so this is 4/3. That is multiplied by pi. This is pi. That's multiplied by r cube. That's the only difference. R cube. R cube. This is here power and this is cube. Something wrong somewhere. E101. Where is E101? Okay. D101. D101 into C101. C value. I did not give value of this, actually that's an error. Sorry gentlemen, no problem. Let us bring it here so that we'll give value of R, let us say 25. That's an error actually. I just missed one row, and so we will make it like this. Just symmetrical position. Now let us see this actually, then it should come here rather than there. So this we cut from here. Pi is here, so pi is here. It doesn't matter anyway. Coefficient is there, so coefficient is here. It doesn't matter. Let's see like that. Volume is this. Now we'll see what actually 4 over 3 pi r cube. 4 over 3 we have, pi we have, r is here. So this is E102. This is coefficient D102 is pi, and C101. It was 102 actually. So it is 102 now. Fact is this. So we got value. So you can say this is first of all I say open cell is here, so that it is clear. Open cell is here, so 25. In this case it can be any value, whatever value which you can take. So this is here, I just reduce decimal places and this is put in here. So formula is 4 over 3 pi r cube. 4 over 3 is here, and it is 4 over 3. We will just, for example, I write without that. This is 4 over 3, so that it's clear to you. It's 4 over 3. Oh my God, it's in date. Leave it. Let us say apostrophe here. Let us say apostrophe. Where is that? It's here. No, it's not that. There's a kind of apostrophe. Here it's there. Oh, not that. Apostrophe 4 over 3. So the text comes as text. So it's okay now. We will put 4 over 3, and this is here answer. So 4 over 3 volume here is 4 over 3. We can say 4 over 3. 4 over 3. It is here. This is E102. Pi is here. This is D102, and R cube. R is here. C102, and that is cube. This is volume in cubic meter. Volume in cubic meter or meter cube. Cubic meter it is. Volume. Now surface area we defined. Surface area. Open cell, not cells. This is one cell, so I say open cell. There is also open cell, one cell. We got not two cells, so I say open cell. Here two cells, so I should say open cells. Open cell, open cells, open cells, open cell. Okay. Now we are not completed sphere yet. We have surface area 4 pi r square. 4, let me see formula if I'm not wrong. Sphere is, it says there, sphere, sometimes 4 over 3 pi r cube is cubic unit, and surface area is 4 5 radius square. 4 5 radius square. 4 5 radius square, that's right. So I put 4 pi radius square. That's right formula. And what to do then? 4 pi radius square. It should be in square meters. Square meter, that's okay. It should be in square meter, no way out. And what we do here now, we need 4 and we need pi. So coefficient here should be, you can say, this is coefficient I can write here, or there, wherever not. Coefficient I can write here. Coefficient, the coefficient is 4. 4, that's coefficient here. And pi is already there. We can use same pi. And r square, r is there. So we have coefficient here. This coefficient, because we have to calculate here, let's say 4. That's coefficient. We have to take coefficient first, and then we have to pi, we have to take pi, and then r square into r to power 2, r to power 2 square. So this is that answer. This is that answer, square meter. So we have solved formula for spherical volume, and you can say spherical surface area. If you want to see earth surface area and surface volume, I'll show just now if it's right. Now radius, let us say, is 12,500, diameter, so 6,250, 6250, oh, sorry, 6 open cell, this is 6250, let us say, and you can say it's not coming in this calculation, but it is there, don't worry, it is there, it is there, it is here, it is also here, it's there, don't worry about that. So this is there. So let's go back to previous one. It's 25, base of 25, it's this one. So you got sphere, spherical volume, and spherical surface area. Now we go to cylinder. Cylinder. You know cylinder. There is a circular surface at top, and circular surface at bottom, and this circular surface vertically projected, vertically connected. So there is a circular vertical surface, and there are circular two horizontal surfaces. That is called cylinder. You know it very well. So we do that. What to do with the cylinder? Now volume of cylinder, because in cylinder we know radius and height. So we need here radius and height. So what we do, first of all, we have to, volume is pi r square h. Pi, r is radius and square, and that is h. And curved surface, its curved surface vertical, which is, because we need circumference of this, so 2 pi r into h. So let me correct this formula because multiple are mixing. And then total surface area is 2 pi r into h. That's just where you got 2 pi r into h, that is plus 2 into pi r square. So we need r, we require r here, and we require h here, and we require pi here. R, h, and pi, and of course there's a coefficient 2 for surface, curved surface. So we have to put this in order. So we can say, okay, we bring it here, no problem. We can bring it here. We have to, okay, let us put here, no problem. Volume you can cut here and put here, okay, no problem. There is space here for radius, so radius and pi we have here. Radius and pi we have here. Actually, you should put, I think this is where I make radius and pi put here. So radius and pi we have, then we put here, and of course I get some space here in between so that we have 4 lines rather than, hold on. Some error, we can, if make the error, you can just delete that, undo that. So we actually need 4 just for our comfort. This is what we need, require here like this. Okay. So radius and pi, and radius in meters, we can say here radius in meters for us. And pi is there, and we can say r is there. So open cells are here in 4th. So we can say open cells are here. Here it will become 2, 1, so open cells. And volume we have here. We have coefficient, that is coefficient 2 here. One coefficient is 2 here, and 2 pi RH. That two coefficients, two coefficients. So we'll say coefficient here. So we'll shift another one. Let us keep it off from here. We cut here and put here. So we have space for coefficient. We can say coefficient here and coefficient there. So we can say this is our separator. Now volume is here pi r square h, and the coefficient are 2. We can say here, let's say first of all r value is here, let us say 15. 15, the value of r 15, so this is 15. Pi is of course there, we can bring it here, no problem. Coefficient is 2, let us say 2, because 2 pi rh, and other one is 2 pi r square, so there are two coefficients. So this is, we will name them better, so that we can keep same, but let's name them separately. So this is for 2 into pi rh coefficient. This is for surface area, I guess. For circle 1 and for surface area 1. We do have value, we have radius. And for circle, we can say circle coefficient. This is circle coefficient, and this is curved surface. Curved surface. Or vertical surface we can say better, just to avoid vertical surface. Just for understanding, I'm writing this vertical surface. These two coefficients. Vertical surface. This is 2 pi r square. This is for, I mean to say, pi r square, because we are using in circle twice, and 2 pi r h we are using also for vertical surface. Both coefficients are here. Now we keep on further how to move it. Now volume is cubic meter. You can say cubic meter is here, cubic meter, and curved surface in square meters. So this is square meters, and this is square meters. This is square meters. So what we do now? Hold on. Now vertical surface. What's a pi r square? Volume is pi r square into h. Volume. Let's find what's pi. Let's say pi. This is pi r square. Pi is there plus pi is there into r is there, and its square is there. Square is there into h. Where is h? Yes, we missed height. See, we missed something. Hold on then. Let's finish. We missed height. R we took, but we did not take height. So no problem. We will move it like this whole to another place, and because we need that height here, we missed that one. So we will keep height here now, add it to that one. That's the benefit of this. So we can say height. You say height. Height, and this height is h. Let us say it is h. H. Height is h. Okay. So this is h. We can add into this. It can be, say, it can be 20. Let us say 20. Anything you can take, whatever you can. So we have that requirement fulfilled. So again we say what to do with this. Let's say pi plus, this is pi into r square into r square into h, and this is h. So we got this volume. Pi r square h, volume of this cylinder. We got volume. Now we have to find curved surface. In curved surface, two circles are there. 2 pi r h. Pi r is circumference, and that is twice circumference, and circumference is multiplied by height. We get 2 pi rh. That is a vertical surface, curved surface, vertical. You can see curved surface, vertical. Curved surface, vertical. Surface vertical. A little dark here. Vertical. Curved surface vertical. So we are saying 2 pi r. Pi r is circumference, and 2 pi r is circumference. Pi is circumference. 2 pi r into h. So we say here 2 pi r into h. Let us see plus 2, that is your vertical surface, into, it's dark, into pi into r into height, so this is that. G107, that is vertical surface coefficient, 2, then E107 pi, then R, this is R, 107 C, and then D is this height. So this is what is this. Then this is, now we have to find total surface area, that is 2 pi RH plus 2 into pi R square. So this volume pi R square H, pi R square H, 2 pi R square H into 2 into H, pi, one is volume, is this volume, actually I'm talking surface area. So curved surface vertical is this, and horizontal we have here. Curved surface vertical is this, then we have to take a square of circle, pi R square, that is pi R square, 2 into pi R square. So we can say circle is circle is here, that is square meter, and that's pi R square, you can say. Of course pi R square, that is, so add pi R square, oh, something wrong, pi into R square, add, I think it is wrong here, it is here, because it's not formula here, pi R square. So we should even take this bracket out here from pi R square, this is, so it is here. We'll take here now pi square is 2, pi R square, pi is here, into R is here, into power 2, that's here. So this is here, you can say that's pi R square, pi over 7 R square C107. Now total surface we can say square meter, this is curved surface is 1, and pi R square there are 2, so we can say plus curved surface is 1 time it is, and plus this is 2 times, because 2 times you can say circle coefficient we can take if you wish. This is J107, this is pi, that is J1. Hold on, what I said. First we say curved surface is this one, plus curved surface is this, circle is this one, into 2, you can take 2 directly, or you can say from there here circle. So that's it. So that's it, and it's here. So this is, you can say again, I107, I is curved surface, that is 1 time it is done, and J107, that is square circle, 1 circle, and multiplied by F to 107, that is 2. So we got our value here. So this is 31. So we got cylinder solved, and there are 2 variables, so we can see them here. We got 2 variables, and 2 variables are there. No other variables, all fixed. So all are formalized. So that's one. Now cone is left. I think cone, because of darkness here, I won't be able to do it today. It will take some more time, because I have to fix ranges as well. It's not simple. So how many formulas we have worked on? We have geometrical formulas here, square, rectangle, triangle, equilateral triangle, then isosceles triangle, right angle triangle, circle, and also we did a sphere, cylinder, and cone is left. So let's say it depends on time. Now light's a problem because I'm not sitting with bulb here. So anyway, whatever it is, I think we have to be happy with something you have done. Important point is you must understand. It's not simply I'm explaining. Explanation should be, it should go, I mean to say, understandable, pickable by people. We'll work on this later. So now, so I prepared a lot at home, and I'm demonstrating to you. Then I'll take it next day, probably when I have a chance to show it to you. So I think you can understand them well. And this is nothing but, how to formalize this one here is something we can say is not worrisome, but it depends. You have to have patience for some time during applying your formula in format. You can say a verb is called here apply your formula to convert it into, just enter variables in that state and you can get answer immediately. This is called application. Now it's very, very small application. I have shown to you much complicated on Excel sheet designs, analysis, Carney's theorem and others that will take time to perfect in, but now basic is very important. How to use caret, how to use this power sign, how to use these mathematical signs, how to use bracket, and how to have trial, how to try to compose a formula rather than calculation, because this you can say like macro, although it's not macro, but it's the same way, because macro may do one or two trial, or you can say two variables. Here you can keep as many variables as you think is right in one formula. Any number of whatever number of variables can be that you feel you should use, but you should be careful about that. Once you keep them, it should be variable only, and you can change those values. Don't touch formula results. You can't touch them where there's a formula sign. That's why important point. If you touch them, you will lose your complete format. You have to protect it until you protect your whole sheet by leaving open cells for these highlighted editable cells. This is very simple, not very complicated. If you can try to understand that, the point is important. If you can try to understand that everything is easy, everything is fine, but you say no, it's not, then question arises, means how to handle that. So it's nearly 1 hour and a half. So I would not go further because I know it's mathematics and it's composition of formulas and format, and it's very boring actually. It's boring only while you compose it, but it's not boring in fact if you do it rightly by understanding, and you have a clear picture of what you have to do. It's slow, of course, it's slow, but during design, it's slow. Design of formula format. Once you design that, you have basic understanding, You can go to whatever extent possible. So with this, I will take leave from this. First, I wanted to do more, but I don't want to bore you because this is very boring topic, but very useful one. And I think, well, I don't want to take more time because I'll close it now. It's very important. I'll continue later on. Thanks all if you are viewing, and you may view also in future.